me opportunity to share my knowledge and experience with you all expert. And thanks to all techie as well for taking your time out to attend the session. So the agenda is planned in this way that we will be focusing mainly on our major problem, which is we often hear from technical managers or technical people or from the users that our database is slow, and that is the main agenda I have picked for today's session, wherein we will be trying to understand what is the main reasons behind slowness of database, and we'll also look at the statistics of database performance and its health and major issues for the given period of time. So how we will progress is we will look into the internal Postgres extensions that helps to understand the database statistics programmatically, meaning we will be running some SQL queries to look into the server statistics like connection statistics, CPU uses, IO uses, whether there is any latency and waitings and blocks, etc. And then we will try to, understand, diagnose it, and try to understand the root cause of it, and we'll look into the solution part of it. And at the end, we'll try to focus on, using a free tool, how everything can be seamlessly and most fastest way, I can say, and easiest way how we can look at all these statistics. So let me go to next slide. So the major problem with the slowness from the DB engine side is because of query execution, wherein sometimes developer would write a query that is resource intensive, and sometimes due to missing indexes or complex join or sorting which doesn't utilizes the proper indexes cause severe or heavy CPU usage, and those are even called as poorly optimized query. And sometimes it could be a high number of users logged into application. There will be many concurrent connections, and those connections are concurrently executing several queries. On top of that, also load of queries happening on the database side, and we need to understand what are those exactly. So and there could be other reasons like even the indexes created by your SQL query is not utilizing those indexes. So we'll try to uncover all those statistics basically. So before we dive into technical side, I would like to introduce myself. My name is Chandan Kumar, and I'm currently based in Bangalore, working for a company called Philips. And I've done master in computer application. I have 14 years of experience mainly into database side. And I am since being a database enthusiast, I have developed a few tools for monitoring and backup purpose, purely on the DB side. And this is my LinkedIn URL too. If you would, I would love to connect with you all. And this is my LinkedIn URL basically. And I'm also reachable at these emails basically, which I'll share you at the end of this session. So first, we will look into the technical side, okay? That what are those statistics or extension that is needed for understanding the resource uses of Postgres. Basically, we will add extra statistics, which is like adding a extra function to Postgres without changing its DB code. And it gives a power to a DB or developers to look into main statistics. So system stats extension will help us in understanding CPU, I/O, memory, and load-related information. And PG stat statements will help us understanding expensive queries, blocking queries, and queries level, basically the information. But to enable that, we will use these two commands. We'll just simply, it's a small command to enable these extensions with this two things. I have done this already in my dev environment, and now what we'll do is we'll simulate high CPU I/O blocking expensive query scenario in our dev environment. So I have written a few queries to simulate high load on the server for our test purpose. And we'll try to, which is basically a common scenario in the production environment, which the production server keeps doing some of the other things. So we'll try to simulate it. And I have some sample queries for that. I'll just run it in parallel, which is like, it's uploading data into a particular table for around, I think, 1 lakh times, and I'll also create another session to run the same query in other session as well. So this will, run for a minute. And the other thing, at the same time, I would like to understand what is the, server uses. Basically, if we run all these queries, we'll get to know what is the current CPU and memory utilization, I/O usage, etc. Okay, these are the two queries. Basically, what it will do is it will insert 1 lakh records from one session, and the other session is also like, it will insert record into this particular table around 1 lakh times, and it will take some time basically to do that. Now I have also written a few queries that will read special function, which is provided by these statistics, basically the extensions. Okay, so once we have created the extension, it will give us access to certain function called PGSys CPU info, which will give us the CPU utilization information, and we also have PGSys CPU usage info, which will give us the CPU current usage time. And the other function is called PGSys load average info. Basically, it will aggregate the CPU utilization into 1 minute, 5 minute, 10 minute, and 15 minute of time frame. And similarly, we have several other queries which will tell us about, this query is responsible for giving us information about disk usage. The other query is about, it will give us the query details, and it is all in aggregated format, like aggregated in the sense number of queries was hit, how many times it was hit, what was the read amount of time, how many rows affected, all those details we will be able to get it through this query. I'll share all these queries at the end of session. I'll be little fast in covering all this because if we go through it, it will take a lot of time. So I'm just telling these are system inbuilt function, and we can get the input of all these statistics from these functions basically. Similarly, to get the connection count at that particular time, we have this activity function name, and to get the weight related details, we'll also use the same function, and we'll get all the waiting event name along with its duration, like how much it was waiting for particular category. And similarly, I have this SQL query to understand what was the infected blocking session and who was the responsible for it, and what was the duration of blocking time affected by other guy. So these are the system-defined function which we'll use while simulating all these environments. So I will simply create one more session here to do the query part. And let me paste all this here. Now, just to look at this, I simply, okay, it is working perfectly. Now I will simulate the load and load into my test machine. And at this time, let me look at the CPU usage. So it is ideal, but other places it shows me that everything is null, but I have just started, so probably because of that this is null and it is not giving me much meaningful information. But in real time, we'll have some information saying this much CPU was utilized. Now this is again averaged out. Since we just started, we are seeing everything 0. It's on my laptop, so no meaningful information, but you guys will get it. So now we started seeing, because we just started data loading, and it says, in 1 minute this much CPU was utilized. After 5 minutes, in the last 5 minutes, this is the aggregated approximately CPU usage. All this information we are getting. And similarly, to get these uses, we'll get disk related information, how much CPU, how much particularly each drive is utilized and what is the free space. And if we look at the top queries, we can find out, these are the queries. Especially, we are mainly interested in what is the total calls versus how much CPU time was utilized. So these two are the main interesting columns we should look for while understanding how much load specific query is generating on the server. Now, sometimes, we'll have to also look at the total number of connections that is on the server. So we can see active is just 3 and 3 are idle. This gives us understanding that, our server is not having heavy load, or, in production environment, it will tell us that, okay, this is the number of connections. Now, waits. Waits is something like, this had been waiting for this much of duration in seconds to process a specific request by the client or by the application. And this is split by database. So we can understand which database is heavily, waiting from a specific wait event and what is the duration of it. So we will get to understand that, okay, we should, whether the other rest of the database should be splitted to other server and kept it in same server. This will give us understanding, okay, which database is having heavily loaded and it is waiting for some process to finish. So it could be because of, sometimes the CPU and the IO have bottleneck, right? So sometimes if we have hard disks that is old generation hard disk and not the latest SSD, so it will give us the IO related bottleneck, and we can understand from this wait report basically. And this particular query is used to understand what is the blocking environment. Okay, so this load is still running, and let me create the blocking simulation. Okay, I have one table basically wherein a records are there in this table. Few records are there. Blocking is something, I have created a transaction, and consider in a production environment where the transaction can take a longer time, and I'm trying to acquire a lock on the other records which is locked by other session, other users or other application, whatever it is. And at the same time, that is also trying to access my records, and so the both sessions are basically waiting for each other to release other's log. So that is when the blocking happens. Okay, and now it took about 4 minutes to complete. At least it got executed. Now I'll simulate the blocking environment. Okay, so basically it will try to update a record and it will wait for 60 seconds. And while, sorry, I just selected only one command, I'll execute it in whole. Now, at the same time, the other transaction is also trying to, acquire the update, which is being handled by the other session. So if we run this, SQL query to find out the blocking session, we can see easily that, some particular, query is waiting for other session to be released. And what is the duration? This is the column we should look for. So now, as we have gone through so far, to understand, what is the load and what is the health currently happening at the server level, we can, mostly what DBA does is it will generate into a HTML file, and they will keep trying to receive all those information on a daily basis or on an hourly basis or on demand basis as and when they need it to analyze the server health. And they can put it in, cron job or scheduled task to get all this data into a report format. Now, I have simplified all these work actually. Before we look into other solutions, we will try to understand what is the solution of these problems. Basically, I'll talk in general because each topic has, in-depth explanation, and each scenario will differ. Each scenario will differ in its own use case, basically. But in general, what could be the solution is, whenever we write a transaction, we should limit the data for retrieval or for write purpose. And it should be very small in scope, and it should be very quick, and ensure that all those queries that users in the transaction should properly utilize the index. Otherwise, it has very heavy seek and index scan operation, basically. And it is recommended to use SSD hard drive. We should have powerful servers, and if we have multiple databases on a single server, and if the database size is very huge and heavily loaded, we should consider offloading the database to multiple servers instead. Having a load balancer or distributed environment is better for read purpose, and in a production environment where there is high load, we should consider having a load balancer as well. Okay, now having said all of these, is there any easier way to do all this, right? So I have written a small free tool for everyone, and anyone can download and just use this. So it's just like, you download this tool called DB Health Pro, and it is available here at this site. If you just go to mssqlplanner.com, and it's called DB Health Pro website. So you simply download this package and extract it, and you don't need to install it. You simply hit exe, and this application will pop up. Now, how easy it is to see and analyze all these reports is you simply register your Postgres server, and click on Generate Health Report. So basically, it will run all these SQL queries that I just explained to you here in this demo, and it will gather all those data, save it in Excel format, Excel sheet, and prepare a nice visual graphical format, and you can easily read and understand it. So basically, the same thing which we saw, the CPU utilization, connection counts, memory uses, and how many, per database, how many commits is happening or rollback is happening. We can see all of those information, how heavily database is loaded. We just saw the weights related information. We can see, okay, Postgres database was the one where there was high weight. And, if we want to see tuple level of information, where how many reads returned or, updated, committed, deleted, everything is happening, we can see all those numbers here. And this is same for graphical representation for all these data. And at the OS level, if not only on the database side, if you want to know which particular process is utilizing how much CPU and memory, we have such information available here. And at the blocking, the time when it was hit, there was no blocking. So that is why we see 0 records here. But since it fetches all these reports at the runtime, so we are seeing the moment when it was this report was generated was not having any blocking. And at the next tab, we can see easily the query, expensive query list. And this graphical representation says query number 1 is having highest CPU amount utilized compared to other all servers. Now, we just inserted some 2 lakhs of records. We can see this query here also. So it is basically live, and at the time when you run it, it gets live information. And this is what OS level of information it shows, and what is the memory setting, configuration setting of the server, everything is available here. And if we want to understand the disk usage related utilization report, we have all this here in this storage information tab. And the good thing is, you can also, simply schedule these reports automatically to be created at particular place you want. So you can schedule it to create all these reports basically on an hourly basis, minute basis, or daily basis. It's up to you. And once you schedule it, and you can also save it in a shared location so that every DBA or developer can access from particular shared path. So this is the path you can define in your environment. By default, it will create in C drive, DB Health Gen folder. And you can put your shared directory here also. So, this is what I have created, and it also supports your SQL Server, MySQL. You can get all the servers related, all different database technology report in one tool. So now let's go to next thing. What I'm going to do is, I'm adding AI functionality into this, which will tell you exactly what is the problem, what is the high priority problem, what is the mid-level of problems, and something which you can ignore, and what is the solution to that. So that AI will be coming soon in this tool itself. Let's go to another tab. Okay, okay. This is the same thing that I just explained. And okay, now this is my contact information. I think I have covered it very quickly, but if you have any question, you can raise your questions, or it's fine. So I think I'm done with this session, and It was very quick, but yeah, that's all I had to share.
Anybody has questions, I can relay that to Chandan here.
Yeah.
Yeah, hi Chandan. If you have any queries which are killing your CPU, eating your memory, so how can we identify those using this tool?
Your voice was a little bit echoing. Can you?
Is it audible now?
Yeah.
Is it clear now?
Yeah, it is better, little bit better.
Okay. So if there are any queries which are eating CPU or memory, so how can we identify those things?
Yeah, good question. So two ways. One, using your query voice. So let's say, we have a queries, what is that? Extension. First thing is we need to enable the extensions. Now, once you enable the extension, that is, what is that extension? It's this one. PG stat statements. You have to enable it and you have to go to PostgreSQL file. There you have to basically check this, enable this this configuration setting. Once you enable it, you will be able to see all the expensive queries, right? So let's say if you hit this query, you have to, simply PG stat statement is the function name, wherein you can join it with particular database and you can have, under specific database, which are the expensive queries. Like the first one is which you see, it tells you that 944 times it was called. Total CPU time taken was, this is the amount, and I think this is in millisecond, which you can convert into second by dividing dividing it by 1 lakh, and it will give you in second basically. Total second it was taken, and total rows it has returned or processed is 2,800, something like that. So the first, mostly per database, the first top 10 queries which you will see is known as your expensive query, and you can split by database also. So here I just ran few expensive query to load into test database. So I'm also seeing insert command here, which was a bit expensive. So it has captured it here. Now, the same thing in the tool also. If you look at the expensive query tab report, here it will tell you, it is very much easy to understand here. The first first two is a bit expensive to the CPU. And what are those queries? Here it is, the complete list of query. And under which database it has executed? It is test database. How many number of times? 944 times. And this is the CPU time and execution time. Average execution is this, rows is this. IO part I have not captured in this Excel sheet, but if you execute this query, you will be able to see, IO part as well. Here I'm seeing, bulk read, bulk written, and this tells me that this is the amount of IO. Here shared bulk reads, okay, block reads, and this is what it tells you actually. Did I answer to your question correctly?
Yeah. Couple of questions, Chandan. Anybody have any questions? A couple of questions. So, with your tool, can we do trend analysis of what are all the observability matrices we can create and capture? Two, the AI piece of it, if you can showcase anything, that would be great.
Okay. So that trend analysis at the moment is in the development stage. Now what you see is, instantly when we hit generate the report, it will, for a last specific availability of cache in Postgres, it picks from there. Everything will be picked from there, and it will store everything in the Excel sheet. Now, in future, I have another, this tool, which is for SQL Server. This is called SQL Planner, which is very advanced, and it has capability of doing trend analysis, auditing, and analyzing health. It also sends you the alert, and this is mainly for SQL Server. But in future, what I was planning is you can deploy this small tool to your any client on different networks, and you can have a central database server located in your cloud, and it will push all these data to that cloud server, and anybody from any place can access their server uses from that central location. So that is the plan for the enterprise. But this small utility will always be kind of freely accessible for everybody, for community. But for enterprise, there is a different plan altogether. I was just architecting and planning. Yeah.
Any other questions? Right. Thank you so much for your time, Chandan. Appreciate you hopping on this virtual call and delivering this stuff.
Thank you so much, Hari. It was my pleasure.
You don't see the people, but there are some happy faces that going to monitor your stuff or going to download your stuff.
Yeah, sure. Maybe can I share this PPT and the code somewhere via email to you, and so that you can circulate to the folks?
Yeah, we will do that.
Sure.
Thank you, Chandan.
Thank you so much giving me opportunity to present in front of you and to all. Have a great day. Bye-bye.